Argonne National Laboratory. The start of the nuclear age began just miles from our school. Nuclear energy was born at the University of Chicago during the height of World War II. Scientists came together to research a solution that could end the war, but what they discovered was much more. On secret orders from our Commander-in-Chief, Franklin Delano Roosevelt, these scientists from around the globe began the Manhattan Engineering District. Until the 1930s, the only subatomic particles that were known were the electron and the proton. Some scientists questioned this theory and believed there was a neutral particle in the nucleus. They proved to be correct, as the neutron was discovered in the 1930s, and in 1938, nuclear fission was first accomplished in Germany. The Italian physicist Enrico Fermi discovered the same phenomenon 4 years earlier, but misidentified it as new elements. The discovery of fission, or splitting atoms, was important because it paved the road for the potential for a sustained nuclear chain reaction. This type of reaction had the potential to produce unlimited nuclear energy, which could be used in war. During the 1930s and 40s, over 100 European refugee physicists, including Albert Einstein, Enrico Fermi, Leo Szilard, and Eugene Wigner, fled to the United States to escape persecution from the Nazis. These scientists continued their nuclear fission experiments when they came to the U.S. At the same time, the German military was working on constructing a nuclear bomb, and they had more time and resources to be successful. It was essential that the Americans' work be kept secret from the Germans, as they were unaware that the U.S. was constructing a nuclear bomb as well. Several scientists approached Albert Einstein in 1939 to sign a letter to President Roosevelt that explained that uranium could be turned into a new and important energy source in the immediate future. It further explained that a nuclear chain reaction could be sustained and generate large amounts of power as well as radium-like elements. The letter stated that this could lead to the construction of powerful bombs. President Roosevelt's response to Einstein's letter was to authorize the Manhattan Engineering District. This occurred the day before Pearl Harbor was attacked by Japan in December of 1941. The goal of this project was to construct a weapon that could be used to end World War II. The key players in the Manhattan Engineering District were its leader, Enrico Fermi, and other scientists such as Walter Zinn, Vannevar Bush, Leo Szilard, Edward Teller, and Eugene Wigner. While doing my research, I interviewed Dr. Roger Blomquist, who has worked at Argonne Labs for over 30 years. He describes Dr. Fermi's role in the project.
So Fermi was really kind of the beginning leader of Argonne National Laboratory. He was the real intellectual giant, and the other guys were really smart too, but Fermi was an unusual scientist in that he was really good at experiments and really good at theory. And most scientists are good at experiments or theory, and they're weaker on the other one. But Fermi had it 100% on both parts. So he was the complete physicist.
The first pile would be called Chicago Pile 1 at the Metallurgical Laboratory, or METLab. Fermi was given the job of building the pile for a self-sustaining nuclear reaction. Doctors Szilard, Wigner, and Teller were important because they were the scientists that drafted the letter to President Roosevelt and asked Einstein to sign it. The first mission for these scientists was to build a functional nuclear bomb before the German military in order to bring an end to World War II. Fermi and his team built a nuclear reactor known as the first pile. This pile was set up under the unused football stands of Staggs Field in a converted squash court. The pile would control the enormous amounts of released energy produced after splitting atoms. The lab also built control rods to stop the chain nuclear reaction by absorbing free-flying neutrons that would split other atoms and thus release energy. The reason these control rods were so important was because if the reaction was left to continue too long, the level of energy would become infinite, and the resulting heat would melt the reactor. Fermi and his team achieved this sustained reaction on December 2nd, 1942. Einstein realized what would happen to the people of Japan if America retaliated with an atomic weapon. He sent a second letter telling President Roosevelt to avoid using a nuclear bomb. He suggested that the United States government ask for the Japanese to surrender prior to using the atomic weapons. This letter came 3 weeks prior to the first bomb being dropped on Japan. On August 1945, the American military flew over Hiroshima, Japan, and dropped an atomic bomb. Hundreds of thousands of Japanese people died as a result of this bomb. Then, while Japan was recovering, a second bomb was dropped and exploded in Nagasaki, Japan. Again, the result was devastation. The Americans threatened to drop a third bomb in Tokyo, Japan. This was too much for the Japanese to consider, and their military was forced to surrender. Thus, the Manhattan Engineering District did achieve its goal to assist in the end of World War II. Even though so much death and destruction had come out of America's actions, something good did happen. Because the war had ended, the world was at peace. These scientists were now free to do whatever they wanted with their research. They decided to establish a laboratory and explore other sciences of the world. They first moved the MetLab to Palos Hills in 1943. They reconstructed the pile at this site and called it Chicago Pile 2. This laboratory was affiliated with the University of Chicago and later, in July 1946, renamed it as Argonne National Laboratory because it was in the Argonne Forest. It was created to carry out the work that Enrico Fermi and his partners had begun on nuclear energy. They chose Illinois because there were many natural resources, especially inexpensive land. Also, Illinois was in the center of the United States, so it was easy to send information on nuclear energy throughout the nation. There have been many challenges to continuing nuclear research. Even though nuclear energy is clean and efficient, it is not always chosen over burning fossil fuels. One of the challenges has been that the general public is worried about what may happen if there is a nuclear accident. In 1978, the nuclear plant in Pennsylvania, named 3 Mile Island, had a partial meltdown of one of its reactors, and a tiny fraction of radioactive gas and iodine was released into the building. No one was injured, but hundreds of thousands of people had to evacuate the area. Because of this accident, the nuclear power program has been slow to grow. Another challenge is that it is very expensive to build new nuclear reactors. Finally, it is hard to convince people to change their power source if they believe burning fossil fuels is safer than using nuclear energy. Many accomplishments have been achieved with nuclear research. Argonne invented the zero-power reactor. Argonne used a boiling water reactor to develop the first nuclear-powered submarine, the USS Nautilus, which heats water and turns it into steam. The steam is then pressurized into a turbine to power a generator and make electricity. In 1954, this submarine was the first to complete a submerged trip all the way to the North Pole. Nuclear power allowed the Nautilus to remain submerged far longer than the submarines using fossil fuels for power. Scientists suspect that the Nautilus could literally have run for years if Argonne had not shut it down. Argon has influenced the development of reactors throughout the world. After the nuclear accident in Fukushima, Japan in 2011, Argonne led a team to build reactors to prevent a similar disaster. In Fukushima, an earthquake caused a tsunami that took out the power supply to the nuclear plant. The reactors were unable to be cooled, and they melted, releasing radiation into the environment. Argonne is making new reactors that are safer and make power efficiently. I believe that Argonne has helped our society and has the right to continue scientific research. Argonne started out as a nuclear lab with a supporting technical science division. Now it is a science lab with a nuclear program. Argonne's mission now is to make people's lives better using science and technology. Argonne accomplishes this by improving how nuclear energy and waste is used and recycled in today's world.